Hi everyone. Today we're going to take the same region and we're going to be revolving it about different axes, and hopefully this is going to help us solidify kind of when we need to use disks versus washers. So essentially when we just have one radius to be concerned with and when we need to identify two separate radii. So I think this will be really good to kind of solidify what we've done in the previous two videos. All right, so let's get started. So we're asked to find the volume of the solid created by rotating the region bounded by this linear function y equals 0 and x equals 3 about the x-axis. Okay, so we're going to draw our picture and then we'll decide whether this is a disk, so solid circles, or whether it's washer, meaning there's going to be a hole in the middle. So let's get this started here. So 2x minus 4. Okay, so my y-intercept is negative 4 up to over 1 each time. All right, so I've got my line. There's my line, y equals 2x minus 4. I'm doing y equals 2x minus 4, y equals 0, so the x-axis, and the line x equals 3. So those form my boundaries. And I'm revolving about the x-axis here. So I'm going to highlight that here. So my region, again, I'm going to double check. So bounded by this line, y equals 0 and x equals 3. So it's this region. So the first thing that jumps out at me here is there is no blank space between this region and my axis of revolution. So that tells me I'm going to have solid disks. I'm not going to have any holes here. So that means really for me, I only have one radius to be concerned with. Because I'm revolving about the x-axis, my radii are going to be top minus bottom. And so in this case, my top function is going to be 2x minus 4. My bottom is 0, so my radius is just 2x minus 4. So now I know my volume is going to be pi times the integral. Let's see, this is with respect to x, so my x values are from 2 to 3. My radius is 2x minus 4, and I know I need to square that radius, and then I have dx. So we can use our calculators to evaluate this. Let's see, math 9, where was I? From 2 to 3. Our radius was 2x minus 4, quantity squared, and we have a dx. So I get 4.189 approximately. Okay, so that's the first one. For number 2, it's going to be the same region. And I'm going to do a quick sketch again. Okay, there's my line. Here's x equals 3. And now I'm going about the y-axis. So here's my axis of revolution. I also know that means I have to integrate with respect to y. Now, here's what I'm noticing. There's that same region, but now you can see in between this region and this axis is a whole bunch of blank space. So I'm going to need two radii. One that spans that whole distance from right to left, and one that just accounts for that blank space that we're going to have to subtract. So I still have a equals pi r squared. My r is right minus left. So I have to look at my two radii. For my big R, the right boundary is x equals 3. The left is x equals 0, so my big R is just 3. For my little r, well, let's see, it's this line, but I need it with respect to y. I need to solve for x. So I get, let's see, 2x equals y plus 4, which means x equals y over 2 plus 2. So now my right boundary is that function y over 2 plus 2. My left is still x equals 0. So my little r is just y over 2 plus 2. So now for my integral, I'm going to have the volume equals pi times the integral. Remember, now we're using y values. So now my y values go from 0 to 2. I've got my big R, and I'm going to square that, minus my little r, and I'm going to square that. And I have my dy to finish that up. Go back to the calculator. I'm just going to square that. 9 minus x over 2 plus 2, quantity squared, dx, and I get 16.755. Okay, so I should have circled here. This one ended up being a washer because of all that blank space. We needed those 2 radii. All right, so then last one, we're taking this same region again. So last time here, scaling is not very good here. Ugh. Yeah, this should have been here. Sorry, that's kind of messy. I still have x equals 3. And now I'm revolving about the line x equals 4. So that's my axis of revolution. So I'm going to draw it in like this. So I have my region. Now, since this is parallel to the y-axis, I'm going to integrate with respect to y. Because it's parallel to that y-axis. Now again, just like the previous problem, in between this region and my axis, I have all this blank space that tells me I'm going to need 2 radii. There's my first one, and then again my little one just accounts for that blank space. So let's see, I've got a equals pi r squared. Now my r is right minus left. So let's identify our radii. So my big R goes from x equals 4 to my left function is this here, but I need it in terms of y. Now we already did that. It was y over 2 plus 2. And I can actually simplify this. So I've got 4 minus 2, so that's going to be 2 minus y over 2. My little r is between x equals 4 and x equals 3. So 4 minus 3, which is just 1. So now again, volume is pi times the integral. My y values are still between 0 and 2. I'm going to have my big R squared, so 2 minus y over 2. Quantity squared. I'm going to subtract my little r squared and finish that off with my dy. So then we get, whoops, math 9, from 0 to 2, I have 2 minus x over 2, quantity squared, minus 1 squared, dx. And I get it's approximately 8.378. And this again was a washer because of that blank space. So again, the idea here was to hopefully solidify the difference between disks and washers and make sure we're feeling pretty comfortable about this process of finding volumes by revolution. All right, we're going to be starting to kind of summarize this up. So tomorrow you'll have practice on both areas and volumes as we're getting ready for the test. See you back in class.